So Stephanie, what would you like to do with this? Integration by parts, again, I told you, right? So stick with your same u and your same dv. All right? Uh-huh. E to the alpha x. Okay. Over here, this is and when you go up with that, good. Perfect. Now, Stephanie, do you see what's about to happen when you do your ultraviolet minus voodoo, specifically the voodoo? You see what the voodoo is going to give you? What are you going to have in that new integral when you do this right here? What's going to be the integrand in there? Forget the constants. Just tell me about the integrand, the big meaty parts to it. You're going to have e to the alpha x, and you're going to have cosine beta x. And that's the original problem, isn't it? That's actually a good thing in this one. All right, so let's just keep going. This is equal to, give me your ultraviolet. E to the minus integral. You want constants out right now? Yeah, okay, give me the constants that are coming out. It's going to turn into plus. Good. Everyone see that? We're going to pull this negative 1 over beta out with this alpha. When that comes out, it's going to switch this minus to a plus. So we're going to have plus, what? Over beta. Good. Integral e to the alpha x cosine beta x dx. Yeah, so why are we stopping? Like, why are we not doing it again? The reason, and let's see if you can see this or not. This is hard to see. This purple is about to get replaced with this, isn't it? And when I do that, that subtraction is going to wind up turning that to a what? Plus, and this back into a minus, right? So it's kind of like I'm going to have this integral on this side, negative, but it's equal to this integral on the left side, which is positive. And what we're going to do is add the integral to both sides. We're going to do algebra. We're just going to do something on both sides and get this integral out of here. Now, let's do it, and you'll see what I'm talking about if you didn't follow that. All right, everybody remember what that is? Because I'm about to erase it. This is about to replace the purple. We've got, what, 10 minutes? We're just barely going to make it. All right, so watch. The original problem, I think I'll rewrite it now. I'm going to rewrite the original integral here. I forgot to mention that this is a classic calculus 2 integration by parts problem. This is one of those, like, you know, the farmer with the fence in Cal 1 type thing? This is like a classic integration by parts problem. Everyone needs to see this one. All right, equals, we've got 1 over beta. We've got e to the alpha x. We've got sine beta x. We've got minus alpha over beta. And then here's where the purple comes in, right? So I'm going to do a bracket. And then you tell me because I've forgotten. It's what? Like negative 1 over beta e to the alpha x sine beta x? No, cosine beta x. So minus 1 over beta e to the alpha x cosine beta x. And then I have plus alpha over beta integral e to the alpha x cosine beta x dx done, right? Not yet, because I haven't done this integral yet. All right, now, so we're not done. This is not an answer, because our answer still has an integral in it. So we're not there. So now distribute this through, which will give me the following. Plenty of paper, plenty of trees. This is now 1 over beta e to the alpha x sine beta x. Okay, distribute here to here. And just those constants go together, don't they, in the front? So positive alpha over beta squared. So plus alpha over beta squared e to the alpha x cosine beta x. Then I have to distribute here to here, which gives me just put the constant out front together. Multiply them. Minus alpha squared over beta squared. And still integral e to the alpha x cosine beta x. Yeah? Breath out. Okay. Now, this is where the magic happens. Well, the magic has already happened. The rabbit's out of the hat. Here's the rabbit. Okay? We just got to put it in the right place now. So this is an equation, right? I'm saying, hey, look, everyone, this integral is equal to all of this, and then this integral, but that's the same integral, right? So what I'm going to do is what we normally do with the equation, since this is minus, I'm going to add this whole thing to both sides of the equation. Add alpha squared over beta squared integral e to the alpha x cosine beta x dx on both sides. I'm allowed to do that? How do what?
You had to attach that one to actually have something in mind for that. Okay.
I had to rewrite the original problem to have the equation, right? To create the equation, I had to go back and rewrite, okay, what was the original problem? This is equal to all this, and there's that integral again on this side. All right. Well, this part's easy. It's gone, right? That part over there I need you to think about. So think about this as being, that integral is this folder, right? If I have this folder and I want to add to it alpha squared over beta squared folders, how many folders would I have? All right, let me do it this way. Look at this right here. Let me call this, like there's a 1 out here, right? 1 times all that integral. So let's call the integral m. What's 1m plus alpha squared over beta squared m? You have to add up the coefficients, exactly. It's this plus this, right? So if this was like 2m plus 3m, it would be 5m. You have to add them together. So the left side actually becomes 1 plus alpha squared over beta squared integrals of e to the alpha x cosine beta x dx, right, is equal to 1 over beta e to the alpha x sine beta x plus alpha over beta squared e to the alpha x cosine beta x. And this went away, so I'm there now. And one last step. I'll do plus c, yes, very good. I'm glad you didn't forget that. But there's something, I want to know what one of these are, right? I'd like to know what one of these integrals is equal to. Divide this out. I'm going to divide both sides by this constant. Divide this side by it, divide this side by it, and we are done. Okay. So when I divide this side, I get, when I divide the left side by this constant, it's just this, isn't it? And then, It's all of this junk right here, which was everything up to there. But I want to divide that whole thing by 1 plus alpha squared over beta squared. I don't need parentheses because I'm dividing the whole thing. Plus C. We're done. Now, I pushed y'all a little bit today with this problem because normally when I do this problem in class first time, I let alpha be 1 and beta be 1. And the problem is much easier without the alpha and the betas in there. Much easier. Think about what the answer would be. I'm going to leave the alpha here and the beta here. What would the answer be if alpha was 1 and beta was 1? So, for example, if I had given you e to the x cosine x dx, according to our work, it would be what?
E to the x.
Yeah, just e to the x sine x plus, those are just ones, right? So e to the x cosine x all over 2, so I could just put 1/2 here and 1/2 here plus c. And it'd be a nice clean answer if alpha and beta were 1. But I thought I'd push you a little bit to see how you handle this, all these alphas and betas, because they're tricky. What is your feeling right now? You should feel like Calculus 2 has really begun now, okay? We are now getting into it, all right? Here's your homework assignment. Begin the homework assignment. I would not expect you to necessarily complete it all because I haven't covered everything, but you should be able, with my homework videos, solution videos, you should be able to handle a majority of those. Yeah, so now the ball's in your court. You got to go punish yourself. Go suffer. All right. Attendance, sorry. Who did not get called? I need your names. So just, we'll start out here. Go ahead. Sandoval. Yeah, give me last names, easier for me. Sandoval. Say again? Okay. Ramos. Reyes. Gaitan. Oh, wait a minute. We took a test today, didn't we? I mean, a quiz? Did anybody not take the quiz? Okay, I just need to make sure I get your attention. Everyone else can go. I'll take it off the quiz. I forgot about that. What's your last name again?